Okay, our next problem is going to be y is equal to x minus 1 over x times x squared minus 1 over x squared. Same exact deal. Yeah, you've got first times the derivative of the second plus the second times the derivative of the first, but because you've got these ugly fractions, you need to rewrite it first. So rewrite it as the following. Y is equal to x minus 1 over x. Well, actually, I don't want to have this 1 over x here. I have x minus x to the negative 1 power times x squared minus x to the negative 2 power. Make sure you understand this, and I kind of got these a little bit close. Hopefully they're not crowding out for you. So you have x squared minus x to the negative 2 in here. So you just basically convert it so it looks more like a polynomial. This is sort of the bottom line. Let me change colors here. But you work exactly the same way. So dy dx is equal to first times the derivative of the second, x minus x to the negative 1 power times the derivative of this guy, x squared minus x to the negative 2. Take the derivative. Plus the second term, x squared minus x to the negative 2, times the derivative of the first term, which is x minus x to the negative 1, take its derivative. So now we just have to work with these derivatives. dy dx equals, this one leave it alone, x minus x negative 1. It just hangs out for a little while. Let's take the derivative of what we have here. The derivative of 2x, or I should say x squared, is 2x because the 2 comes down, x to the first power because I subtract the exponent off, minus. I'm going to have this guy. Negative 2 comes down and multiplies with this, making it positive. 2x to the negative 3 power. The reason it's negative 3 is because I subtract 1 off that exponent. Negative 2 minus 1 is negative 3. The reason it's positive is because these guys multiply one another. Plus, leave this alone, x squared minus x to the negative 2. And here, I take the derivative. The derivative of x is just 1. The reason it's 1 is because the 1 comes down, which gives me this. X to the now 0 power, it just disappears. Now, next term, negative 1 times this is going to give me a positive, let's go ahead and write the 1 for right now, x to the negative 2. The reason it's negative 2 is because I subtract 1 off. Now, I don't really have to write this 1 here, but it's okay. I'll just leave it there. So this guy multiplies, gives me positive 1, x to the minus 2, because I subtract 1 off. Okay, now dy dx. What am I going to do next? Let me go ahead and switch colors, just to break it up a little bit, because it's starting to run together a little bit here. The next thing I need to do is just basically, well, there's a lot of ways you can go about it, but I would recommend doing FOIL here, and then FOIL here, and then just collecting your terms and see where they fall. So let's go ahead and do that. 2x times x is going to give me 2x squared. The inside terms, 2 times that negative 1 is negative 2, times x to the, here you have negative 1 plus 1, so it's going to give you 0 power. Now if you're in a rush, you might just say, well, it's 0, I'm going to leave it out. But I like to leave it this way. That way if I make a mistake, I can go back and trace where I found it. So negative 1 plus 1 gives me 0. Now the outside terms, 2 times 1 gives me 2. X, I add these exponents. Negative 3 plus 1 is negative 2. Okay? And then the final guys is going to be negative, because negative times positive, 2x, and I add these guys. Negative 3 plus negative 1 gives me negative 4. So that's a pretty lengthy guy here. So I'm going to wrap this in parentheses mostly so I can associate it with this, okay? And then I'm going to add to it on the next line the FOIL that I get from this. So 1 times x squared is going to be x squared, okay? Inside terms is going to be negative. This 1 times this is going to give me x to the negative 2. The outside terms is going to give me x plus x, but then I add the exponents, negative 2 plus 2, again give me 0. If I were in a rush or more experienced, I could just put a 1 there, but I'm going to leave it there, that way I'll know what's happening and trace my steps. Multiply these is going to be negative x, negative 2 minus 2, or plus a negative 2, negative 4. So that is really all of the FOIL. A little bit of a pain, but you know, it's not so bad. So don't forget that these x to the zeros, they're really 1, right? and it just helps me keep track of it by keeping it that way. So dy dx, just to tidy everything up, let's go ahead inside of each parenthesis and just simplify it as much as we can. So I have 2x squared plus 2x to the negative 2. I can't really combine those. I can't really combine those. So actually I changed my strategy a little bit. Since I can't combine anything in here, I'm going to write it all out and then we'll simplify it in a minute. So I'll have 2x squared minus 2, because this is times 1, plus 2x to the minus 2 from here, minus 2x to the minus 4 from here, plus x squared, minus x to the minus 2, plus 1, minus x to the minus 4. And I barely fit it on there. So now you really have to go through and just combine terms. And it just becomes tedious. I mean, you're not even doing calculus at this point. This is just algebra. So you see how I say, once you get past the derivative part, the rest of it is just doing some algebra. So you need to be comfortable with that. So the way I recommend doing it is just starting off with your square terms. Here's a square term. Here's a square term. Those are the only two square terms I have. So I'm just going to make it 3x squared. And I have color markers, so it's easier for me. But on my paper, I usually put a dot or something over everything that I've touched. Because that way I know I've got those guys and I can not miss anything else. I've got these negative exponents. I'll save those for later. Let me look over here. I have a negative 2 and I have a positive 1. Those are my only numbers. So I'm going to make this a negative 1. Negative 1, or I should say minus 1. And since I've already gotten those under control, I'll do this guy like this. And I've got those taken care of. Now the only thing I need to simplify are these. Okay, so what I'll do next is I'll say, well, I have an x squared here, a 2x to the negative 2 here, and I have a negative x to the negative 2 here. So that's going to equal plus just simply 1x to the negative 2 power. Because 2 minus the 1 there is going to give me 1. So this is, I've simplified along with this. And then finally, I've got negative 2 times x to the minus 4, and then I have a negative 1. When I add those together, I'm going to get minus 3 times x to the negative 4. So you could actually circle this as your answer. It's absolutely fine, dy dx. But since the original problem had fractions in there instead of these negative exponents, I'll just do the courtesy of putting it back in that form for you. So minus 1 plus 1 over x squared, making it a positive exponent, minus 3 over x to the 4th power. 3x squared minus 1 plus 1 over x squared minus 3 over x to the 4th. A lot of work. I mean, pat yourself on the back. If you follow that, and I hope that everybody can follow that, I think that everybody can follow that, then you're doing some real calculus here. I mean, this is no kidding around. I mean, you're taking derivatives of a fairly complicated looking function, but you got to break it into step-by-step chunks. You do the rule, and the derivative itself is pretty easy, but notice that after this point, it all became algebra. And by the way, that's just the way it's going to be in calculus. So you're going to learn how to do integration. You're going to learn how to take derivatives of more and more complicated things. Doing that is probably not that bad. It's just doing the simplification at the end that you probably won't get full credit for unless you do. So that's why I'm picking these problems that are a little bit more challenging as we go to give you a little practice with what you probably might see as a good question on your exam or as a bonus question or something. So that brings me to the following guy. This is a great problem because it has square roots in it, and I like teaching people how to handle them because they look really difficult, but they're not once you understand it. So what if I had square root of x times, let's do something crazy, cubed root of x minus 1. So you might look at that and say, wow, I have no idea how to do that because I've got these square roots and cube roots and Jason's never taught me how to do that. But you in fact do know how to do that. Let's rewrite it as follows. Anytime you see a square root like this, always write it as an exponent. So this is x to the 1/2 sitting out in front here. Inside the parentheses is x to the 1/3 power minus 1. So now you have the other fractional exponents, and that's not fun really ever to deal with, but they're at least exponents that you know how to deal with. So deal with them. So now you have the first function and the second function multiplied together, so we know how to take the derivative of that. And this is going to be a little bit lengthy, but only because of the fractional exponents. The actual derivative stuff is not hard at all. Okay, so we have the first function, x to the 1/2, times the derivative of the second function, 1/3 minus 1, take its derivative, plus the second function, x to the 1/3, times the derivative of the first function, f to the 1, or x to the 1/2, take its derivative. So far, it's the same as everything else. And I will try to shake it up and switch colors here to keep it a little straight. F prime of x is equal to x to the 1/2 out in front. Now, how do we take the derivative of this guy on the inside? Same as we have been before. This is simply 1/3 coming out of the exponent times x, but the new exponent is going to be 1/3 minus 1. Okay? The derivative of this 1 is going to be 0, so I can close my parentheses off. Now, here you go. Here's a case where it's a little bit of style. The new exponent is going to be 1/3 minus 1. A lot of you out there can take 1/3 minus 1 in your head and get the answer. So if you can, and you're confident in that, just put the new exponent here. For the rest of us, liking to show every step so you can trace through if you get a problem, just write it like this for now. You can figure out the fraction math in a minute and then come back in the next step and fill it in. That's typically how I do it, unless I'm really in a rush, because if I make a mistake, I'll be able to trace up and say, oh yeah, I screwed that up. All right, so here I have x to the 1/3 minus 1. Now how do I take the derivative of this? Same thing. Exponent comes out times x. I have 1/2 minus 1. Okay, let me switch colors. So here, we just need to do a little bit of simplification. After this point, notice it's all algebra. We've done the calculus. Calculus gets such a bad rap. Calculus isn't the problem. It's all the algebra doing all this stuff here. So we'll have x to the 1/2 times, what are we going to have here? 1/3. My advice is to go over off to another side of the board or something, or paper, and work out these fractions. So here we have, this is just separate over here. So 1/3 minus 1. That's the same as 1/3 minus 3/3, just getting a common denominator. Usually in derivatives, you're always subtracting 1. So just do it easy for yourself and make yourself a common denominator by making it 3/3. 1 minus 3 is -2/3. So the answer is -2/3. So what you'll have for your exponent here is x to the -2/3. Close it off. So there you go. That's all you have to do. Now, a lot of you guys could take 1/3 minus 1 in your head and get the answer. That's okay. Just write the answer down if you're comfortable with it. Next, you'll have x to the 1/3 minus 1 times this guy, 1/2 times x. Same kind of thing, 1/2 minus 1. I think a lot of people out there know the answer, but if you forget, just take 1/2 minus 1, which is the same as 1/2 minus 2/2. Just converting this to 2/2. 1 minus 2 gives me -1/2. So it's -1/2. Okay? So the answer up here is -1/2. All right, let me switch colors back. And now we get to do a little more simplification, f prime of x, because we have a 1/3, so I'm going to put that in front, 1/3. Now we have an x to the 1/2 plus this. And here's where it gets fun, because what you have is 1/2 minus 2/3. So what you'll have is, because you have to add the exponent. So let's just be explicit about it. X to the 1/2 minus 2/3. If you know how to do that in your head, or if you have a calculator, just write the answer in. Otherwise, just leave it like this. Next, so I'm going to put a parenthesis around that just so I know it's off by itself, plus. Multiplying this guy by this, I'm going to have 1/2 times x. I'm going to have 1/3 minus 1/2 for this guy because I add the exponents. And then the final guy is going to be minus 1 multiplied here, or I should say 1/2 because the 1/2 multiplies here, x to the -1/2. So there's really not much to do there. So I've got two more fractions that I need to figure out the answer to. I need 1/2 minus 2/3. So 1/2 minus 2/3. What you need to do is get a common denominator. So multiply this by 3 and multiply this times 2. So when I multiply this by 3, it's going to be 3/6. And here, when I multiply by 2, it's going to be 4/6. So when I subtract this, 3 minus 4 is going to be -1/6. So that's what I have, -1/6 there. So the next step, I'm going to continue simplifying. F prime of x is equal to 1/3 x to the negative 1/6 power. Okay? And then over here, I'm going to have 1/2 x. Now I need to add those fractions, or I should say subtract those fractions. And I'll do that, actually what I'll probably do is just erase this. Give myself a little bit of room. So what I need to do is 1/3 minus 1/2. So 1/3 minus 1/2. Do the same thing. Multiply by 2 gives me 2/6 minus multiply by 3 gives me 3/6. 2 minus 3 is negative 1/6. So I'm going to have negative 1/6 there also. Okay? So I'm going to have negative 1/6. And then finally this term is just going to sit out here. 1/2 x to the negative 1/2. Okay, so now I can do a little bit more simplification because I have these guys which are common. But now I have 1/2 plus 1/3. So I'll have f prime of x is equal to, when you take 1/2 plus 1/3, I think doing this we've learned enough. You can simplify that guy and add those fractions together. You're going to get 5/6. So what you're going to have is 5/6 x to the negative 1/6. This adding these two terms together, adding the fractions, give you 5/6, and then minus 1/2 x to the negative 1/2. So we're basically done at this point. I can actually circle this as being completely correct and done, but I'll just leave it as 5/6 times x to the 1/6 power, making it positive in the bottom, minus 1/2x to the 1/2 in the bottom, making it positive. And this is the answer. 5/6 x to the 1/6 power minus 1/2x to the 1/2 power. A lot of work. Step back and look at what we've done. I mean, it's a lot of fractions everywhere. So anytime you have a fraction, which means a square root, a cubed root, a fourth root, a fifth root, anything like that, convert it to a fraction. And then you just have to roll up your sleeves and really make sure you're not making any mistakes. First times the derivative of the second plus the second times the derivative of the first. After that point, you'll be doing a lot of fraction subtraction. Which you'll need to kind of go off to the side of the paper and figure out, or if you have a newer calculator, you can type the fractions in and do it, and it'll just get the answer simplified very, very easily, and not do it all by hand, but I'm trying to show you everything. The rest of it, really honestly, beyond this point right here is all algebra. So like I said before, calculus gets a bad rap because it's really hard. Really, it's not that hard. It's just that simplifying everything and getting it into a proper form is the part that's difficult, or challenging, I should say. And it's only challenging because of all the steps, of all of the tedious steps. So we have one more. I just wanted to give you one grand finale just to show you how to bang through a complicated one like you might see on your test. It's not that bad though, because we were doing exactly the same stuff. What if we had f of x is equal to 3x squared plus 2x plus cubed root of x minus x multiplied by x squared plus 2. So we want to take the derivative of this guy, but we've got an ugly cubed root. So I'm going to have you rewrite it. That's how I always do it. So let's rewrite it as f of x. All this stuff in the front is going to stay the same. 3x squared plus 2x plus x to the, here, it's going to be 1/3 minus x. Here we're going to have x squared plus 2. Okay, so now what we have is three things added together. The 3x squared, the 2x, and then we have the product here. So we're kind of summing everything all together and coming back full circle. We can take the derivative of this and then just add it to the derivative of this, okay, because they're just summed together. But when we take the derivative of this part, we have to use the product rule for this little part of it. So that's what we're going to do next. F prime of x, what is the derivative here? 3 times 2 is 6x to the first power, because 2 minus 1 is 1. Plus, the derivative of this is just 2, because the exponent comes down, 1 minus 1 gives us 0, x to the 0 disappears. Plus, to take this, we have to do the product rule. So it's the first 1/3, x to the 1/3 minus x, times the derivative of the second, x squared plus 2, prime, meaning take the derivative, plus the second term, x squared plus 2, times the derivative of the first term, x to the 1/3 minus x take its derivative. So the rest of this entire problem is going to revolve around taking these derivatives and simplifying everything else that follows. So f prime of x is equal to 6x plus 2 plus x to the 1/3 minus x. How do I take the derivative of this? X squared, take its derivative is 2x. I think we've done that enough times that you can see that. Derivative of 2 is just 0, so that's all I have here. Over here, I'm just going to have plus x squared plus 2. Take the derivative of this. Taking the derivative of the first term is just 1/3 x. And now I have to take 1/3 minus 1 in that exponent because I'm subtracting 1 off of that exponent. And then I take the derivative of this, it's going to be just minus 1 because the exponent comes down, x to the 0 makes it all disappear. Okay, so moving on to another color for the next step. What do I do next? F prime of x is equal to 6x plus 2 plus, when I multiply these guys, I'm going to have 2x, but then I'm going to have 1 plus 1/3. So yeah, you can do that in your head, but for right now, just leave it as 1 plus 1/3 and deal with it in the next step. Minus 2x squared from this multiplication, like this, okay? And then over here, you're actually going to have to do FOIL to figure out all of this stuff. So to make sure I have room, I'm going to go ahead and wrap parentheses around this, and I'm going to add all the terms that I get from multiplying all this stuff out. So I'm going to have 1/3, the first two terms here. I'm going to have 1/3 x to the, and then now I'm going to actually do this fraction. 1/3 minus 1. You can go figure that out. 1/3 minus 3/3 is going to give you negative 2/3. So it's going to be negative 2/3 multiplied by x squared. And I'll add those exponents in another step. Now, in order to keep myself sane here and to keep the board manageable, I'm going to go ahead and do this right now on a sort of a sideboard here. So what I have here is adding these exponents, 2 plus a negative 2/3, which is the same as 2 minus 2/3. So basically, I want to add these guys together, so I'm going to have 2 over 1 minus 2/3. All right, so to make this a common denominator, multiply by 3, so it's going to be 6/3 minus 2/3, which equals 6 minus 2 is 4/3. So it's good to kind of go off to the side of the paper and figure this out, because then instead of keeping this along and simplifying it in the next step, I can just kind of do that right there. So it's going to be 1/3 x to the 4/3. 4/3. Make sure you understand that. Really all I'm doing is I'm taking this guy, which is really negative 2/3, and I'm adding it to 2, and I'm getting this as a result. So those are the first two terms. Okay. Next, I'm going to have the multiplication of this. 2 times 1/3 is 2/3 times x. Don't forget this is x negative. That's negative 2/3. And just to make it clear, I'll go ahead and erase it now and put negative 2/3 once you actually do that math. Okay. So I'll have negative 2/3 for this guy. That's the inside. Outside, guys, negative x squared. And the last terms is negative 2. So I'll just wrap it up. So I'm slowly but surely chipping away through all of these fractional parts. And I'm going to do the same thing here. 1 plus 1/3. Let's go off and figure this out. 1 plus 1/3 is basically going to be 3 over 3 plus 1/3 is 4/3. So if you can do that in your head, great. If not, then that's fine too. So what we'll do to make it manageable is I'll erase this and I'll put 4/3 down. Okay, now I've got everything basically the way I want it. Now I need to try to start adding terms if it's possible. And notice I do have some exponents with the same, or some x's with the same value of the exponent. So I think I'll be able to do some simplification. Okay, first, 6x. Do I have anything else with just an x in it? I don't have anything else with just an x, so I'm going to leave 6x alone. I have a 2, and I have a minus 2 over here. So these are actually going to go away, the 2 and the minus 2. So that's going to cancel out with this. I've already simplified this guy. So everything with red is something I've touched to try to simplify. All right, so I'm done with this guy. Okay, to keep myself sane and keep everything on the board manageable, I'm going to add these two terms together because they both have x to the 4/3. So I need to add 2 plus 1/3. So what you really have is 2 plus 1/3, like this. So to do that, just multiply this by 3, which would be 6/3 plus 1/3 is 7/3, right? So instead of carrying it through and writing the thing over and over again, I'll just put 7/3. Your calculator can also probably give you that too. I'll have, let me keep it black just to keep it all consistent. It'll be 7/3 x to the 4/3 power. And so just to remind myself, I've now touched this term and I've touched this term. So the only thing really that I have left is this guy and these guys here. So what I have x squared right here. So this is an x squared, this is an x squared, and this is -2 and a -1. So I have minus 3x squared. So I've now touched this guy and this guy. And so the only thing left is this. So I have plus 2/3 x to the -2/3. So that guy gets rid of that. So I've simplified everything. So the only thing I have left to do, f prime of x is equal to, just make it a little bit prettier. I'll have, let's move this guy up to the front. So I'll have 3x squared, I should say -3x squared. This guy plus 6x. This guy 7/3 x to the 4/3 power. Plus, and then this, I could leave it like this, but I'll just say 2 over 3x to the 2/3 power, which is nice because then everything's positive exponents. So -3x squared plus 6x plus 7/3 x to the 4/3 plus 2 over 3x to the 2/3 power. And there you go. This is the first derivative of this function. So, you know, this is about as complicated as it gets with the product rule. You just need to take it one step at a time. In this step, in this one, we knew we had these two added together. We could take these derivatives easily. This was first times derivative of the second plus the second times the derivative of the first, but we converted all the radicals to exponents, which are fractional exponents. So because you're always subtracting and adding one and simplifying with fractions, this just gets ugly after a while because you've got all the fractions running around. So my advice is keep everything really, really clear. Give yourself plenty of room on the paper so these fractions don't bump into the previous line. When you simplify things, put little marks under them so that you know what you've simplified and what you haven't. And then when you're doing this fraction arithmetic, don't be afraid to pull out a separate sheet of paper and quickly find the answer there, or use your calculator to get that there and simplify it as far as you can. I'm Jason with MathTutorDVD.com. I hope you've enjoyed this section. Taking derivatives, like I said, it is tedious. But it is bulletproof. Once you know how to do it, you're doing the same thing over and over again. So you just need to use your algebra skills, basically, to make sure that you keep everything straight. Work these problems again if it helps you. Usually it will help most people to watch this video a second time and work these on a separate sheet of paper. The fact that you've seen them once has no problem, no bearing on it. You're going to still get a lot out of it by rolling up your sleeves and working these problems. And I guarantee you, if you can work the problems on this DVD course, then you're going to absolutely ace your calculus exam.